Hello, it's Miss Coletta here, and today I would like to look at now-next equations with you. As you can see here, a now-next equation is an equation that describes how you can get from the now, or the current amount, to the next, the future amount, as one unit of change is made in one of the variables. So for instance, if you're talking about population over time, it would be taking you from 1 year to the next year. It would give you the population from 1 year to the population in the next year. Just like regular equations, now-next equations show the relationship between two variables. However, in a regular equation, you probably see variables like x and y. In a now-next equation, you'll see the words now and next. So when we write now-next equations, there are a couple steps we want to follow. The first one is we want to identify if there is a percent change. And if there's a percent change in the problem, we either add or subtract from 100% depending on whether it's an increase or a decrease. Then we make our percent into a decimal because anytime we want to use a percent change of a number, we need it as a decimal. And then we multiply it by the now. That would be multiplying that percent by the current population or the current amount to take you from one time to the next. The second thing we look for is whether there's a constant change. If there's a constant change, meaning the same amount every time, every year, every day, every minute, whatever our units are, then we add or subtract it depending on what that change is. And then the last step here that I didn't really write because it's just kind of the final answer is to write your now-next equation. And you'll see how to do that in our examples as we go through. Okay, so just a few key words to look out for when you're doing a now-next equation. If you see something like increases by this percent or decreases by this percent, both of these are our key that it's a percent change. And then if it's increasing, of course, we add. If it's decreasing, then we subtract. So we start with 100%, which would be the original amount, the whole amount at the beginning. If it's increasing, we add 5%. If it's decreasing, we subtract. Then you can see here that in each of these I'm converting my percent to a decimal so that I can multiply it by a number. And the number just says now because that would be, we would multiply it by whatever our population or our amount is right now. Then here if you see something like this much money is deposited each year, or you could also see this amount of people move into the country each year, or if you saw something where people are moving out of the country, both of those are constant changes, and then depending on whether we know that value would go up or down, we would either add it or subtract it. So you see here, after we had the now piece, we would add 20 or we would subtract. So these always make a little more sense once we get our feet wet with some examples, so let's take a look. Example number 1. Great Britain has 62 million people. The population is increasing at a rate of 1.2% per year. So I always underline any keywords I see. And I see 1.2%. Write a now-next equation to show the change in population from 1 year to the next. So that's the name of the game. So what I do here is the very first thing I do is I identify my percent change. And here I see it's an increase of 1.2%. So an increase means that I would add it to 100%. So I take 100% plus 1.2% and I get 101.2%. Then the next thing we do is we convert our percent to a decimal so that I can use it. So when we convert our percent to a decimal, remember we always move the decimal place 2 places to the left. Your other option is to divide the number by 100, and we should get 1.012. And that's the number we'll use later in the problem. The next thing I do is I ask myself whether or not there is a constant change. Constant change would be some indication that there's a value that goes up or down by the same amount every year. And I don't see any constant change in this problem. There's no real change besides that population growth rate. So no constant change. Okay, so the last step then is to write our now next equation. Now remember, the point of a now next equation is to get us the next population based on the current population, or to get us the next amount based on the current amount. So we actually start our now next equation with the word next, because we want to know what the next equals based on the previous amount. So here, remember, if we have a percent change, the way we deal with the percent change is we would multiply our percent by our current population. So I'm going to write 1.012 times, and then I would multiply it by the current population. Now here, most people want to go up here and say, oh, well, my current population is 62 million. But we want this equation to work anytime we have a population, even if it's not 62 million. If we go a couple years down the line and we have a different population, we want it to take us from that current population to the next. So instead of actually putting in that 62 million, we're going to put in the word now, which just tells me use whatever number is the population right now. Now the equation is telling us if I take the population right now and I multiply it by 1.012, because that's the percent that it should increase by, is the 1.2% added to 100 and converted to a decimal. If we multiply the percent times the number, we get our new value, our next. Now the trick is we do have to include the 62 million somewhere in the problem. So the way we do that is we have something called the now start, and it just tells you where your equation should start at, what your first value is that you know. And the first value we know is 62 million. Okay, so now that we've taken a look here, we'll go a little bit quicker through the rest of the examples and see how we do. Okay, in example 2, I know the first thing I'll look at is my percent change, so I'm just going to set myself up to be ready to look for that. And let's go ahead and read the question. Harrison takes insulin for diabetes. He takes 5 milligrams of insulin in one dose. Each hour, the amount of insulin in his body decreases by 10%. Write a now next equation to show the amount of insulin left in Harry's body from 1 hour to the next. Okay, so a percent change here. Do you see any number that looks like it tells us the percent that we would change by? Good, it decreases by 10%. Okay, and then because it's a decrease, we know we start off with our 100% and we would subtract that 10% to get 90% as the number we'll want to use. In his body, there's always 90% of the insulin after each hour. And then we know we want to convert that 90% to a decimal so that we can use it with a number. So I move my decimal 2 places, and that becomes 0.90, or just 0.9 would be fine also. Now we look and see if there's a constant change. And there is no constant change here. Again, there's no number that it would be going up or down by each hour. So we're ready right away to write our now next equation. Okay. Again, our now next equation always starts with next equals, because that's what we want to know. We want to know the next hour. And I take my percent change, which is just 0.90, and I multiply by the now. And then the only thing I'm missing here is my now start. And we want to know where Harrison started at the beginning of the problem, and he started with 5 milligrams of insulin. So I'll put 5 milligrams. And that is my final answer. So our goal here at the very end of the problem is to have the equation. That's our answer at this point. What we'll do in the future is use that equation to actually get us to some other information about the problem. For instance, how much medicine will Harrison have left after 5 hours? When will he need to take more medicine if he needs to take more medicine at 2 milligrams? Those kinds of things. So let's take a look. Now we're going to look at some examples that have a little more going on. So what I would like you to do is see if you can read through each of the problems and underline the key information, and then set yourself up with that percent change, constant change, and now next equation headings. And I recommend that you pause the video so that you can kind of think through that process, because when this continues, I'll have my keywords and things underlined in the video. Okay, so hopefully when you read through these problems you underlined similar information, and you can see I'm ready to go ahead and identify the pieces of the problem that I need to write my now next equation. So looking at example 3, the percent change in this problem is an increase of 2%. Which tells me that I take my 100%, and what do you think I do? I add that 2% to get a total of 102%. And what this tells me is that the next year I'll have 102% of the population that I used to have. But remember, anytime we use a percent, we need to convert it to a decimal. So I take my decimal place and I move it 2 places to the left to get the number 1.02. And now we're ready for the constant change. When I read this problem, there is an extra number in here. It says each year 1.1 million people immigrate into the USA. Now, do you think that would make our population go up if they're immigrating into the country, or go down? It would make it go up. So what that tells me is that I have an increase of 1.1 million, so I write plus 1.1. And notice I don't put all the zeros down, or I don't write the word millions there. That's because the units will go in the now next equation. What you want to be careful of, though, is that everything agrees, meaning it's in the same unit. So here this says millions, and so does this. So I can leave off the zeros for the millions because I know that there are going to be units of millions on my answers. So you just want everything in terms of millions. So then I'm ready to write my now next equation. I always start with the percent change, and my percent was 1.02. We know we multiply the percent change times the now. And then if we have any constant change, we either add or subtract it. So here is where our problems get a little longer, because now we have this 1.1. Now I'm going to put the now start, and I'm going to abbreviate now start as NS, because it makes my life a little bit easier. And I know that I start with 314 million people, and this is where the units are really important. This is what tells me, when I write million here, that this 1.1 is also in millions. Okay, so we don't write it in the equation, but we do write the units in the now start. Okay. Let's go ahead and try example 4. So I start with my percent change here, and it looks like Lily's loans are growing at an interest rate of 5.6%, so that's an increase, which means we take 100% and we add the 5.6% to get 105.6%. Now remember, we always want our percent as a decimal, so I move my decimal 2 places to the left to get 1.056 as my percent change that I'll use in the problem. I do not have a constant change here. Lily's not doing anything special to her loans. She's just letting them grow. And then I'm ready to write my now next equation. So I have next equals. Remember, we always multiply the percent change by the now, by the current amount. And then if there was a constant change, I'd put it at the end here, but there isn't, so I don't have anything there, and I just write my now start. Now for thousands of dollars, I probably would put the zeros. I wouldn't write 30 and then the word thousand. It's just when you get into millions where the numbers get really big that I would write the word million instead. So now here you have example 5 and 6, and I would like you to pause the video and see if you can try them on your own. Okay, so hopefully you had some luck with these. Please go ahead and check your answers. You'll notice in example 5 we have that same percent change we had in example 4. We have a constant change though because Lily is paying her loans. Now if she's paying them, her amount that she owes would go down, so that's why we're subtracting it. And when I put that all together, this is the now next equation I should get. Looking at example 6, our percent change is a decrease, so here we subtract it. When I convert to a decimal, I should get 0.985 as my percent change. I have a constant change. The school is adding 24 fish, so that's a positive 24. And when I put it all together, that's the equation I should get. I hoped this helped you get a better understanding of how to write now next equations. Thanks for joining me.